What if the most dangerous animal that ever lived wasn't a dinosaur? What if it was a shark? And what if the reason you can't stop thinking about it is because some tiny ancient part of your brain genuinely isn't sure it's gone? That's the Megalodon effect, and it has a grip on us that no other extinct creature comes close to matching. Dinosaurs are fascinating, woolly mammoths are adorable, but Megalodon is personal. It lives in the ocean, the same ocean we swim in, the same ocean that covers over 70% of this planet, most of which we have never seen, never mapped, never touched. And that terrifying fact is exactly why humanity refuses to let this animal die. The 2018 film The Meg earned nearly 73% of its $530 million worldwide total from foreign box offices. That's not a fluke. That's a global obsession. Then came Meg 2, The Trench. In 2023, negative reviews, nearly $400 million worldwide. Critics hated it. Audiences didn't care. Because Megalodon isn't really a movie monster. It's a myth. It's a fear response dressed up in 200 million years of evolution. But here's what nobody in those movies, nobody in the comment sections, nobody breathlessly insisting that we haven't explored 95% of the ocean ever stops to ask, what do we actually know about Megalodon? Not the movie version, the real one, because the real Megalodon is simultaneously more extraordinary and more mysterious than any film has dared to portray. And the facts hiding inside that mystery will genuinely change the way you think about this creature. So buckle up, we're going deep. Picture yourself on a beach. The water is warm, clear, calm. You wade in up to your waist, and then, somewhere in the back of your mind, a whisper. What if? That whisper is ancient. That's not stupidity. That's survival instinct. Megalodon is the ultimate projection for that fear, the monster our deepest instincts always suspected was out there. The internet has weaponized this. Every few years, grainy footage of something enormous moving beneath the surface goes viral. Every few months, an oversized tooth surfaces as proof. The argument always comes back to the same claim. We haven't explored most of the ocean, so how can we be sure? It sounds compelling. It's also, scientifically speaking, completely backwards, and we're going to dismantle it. But first, let's understand the animal itself. Megalodon, meaning big tooth, was an apex predator that ruled oceans for roughly 20 million years. To put that in perspective, our entire human lineage spans only about 6 or 7 million years. Megalodon had already been the undisputed king of the ocean for longer than we've existed as a genus. Here's the catch. Sharks are cartilaginous fish, meaning their skeletons are made of cartilage, not bone, which rarely survives fossilization. What paleontologists are left with are teeth. Just teeth. For one of the largest predators in the history of life on Earth, our primary evidence is a pile of fossilized teeth. No skull, no spine, no fins, just teeth, albeit extraordinary ones. Megalodon's teeth are triangular, serrated, and in large individuals reach around 7 inches in length. A great white's teeth typically max out at about 2 inches. Hold up your hand right now. A Megalodon tooth was roughly the length of your entire hand, serrated like a steak knife, built to punch through bone. Megalodons had around 275 teeth arranged in 5 rows, and like all sharks, they cycled through them constantly. The ocean floor during the Miocene must have been littered with these things, and indeed fossilized Megalodon teeth have been found on every continent except Antarctica. But now comes the reconstruction problem, and this is where science gets genuinely humbling. For decades, scientists did the logical thing. They looked at the great white shark and scaled it up. That model led researchers to conclude Megalodon was round and stocky, a massively inflated great white, all bulk and brute force. For a long time, that's exactly what the textbooks showed. Then, a 2024 landmark study blew that image apart. Our team re-examined the fossil record and discovered the Megalodon was more slender and possibly even longer than we thought. Therefore, a better model might be the modern mako shark, said UC Riverside biologist Philip Stearns. A mako shark. Long, lean, built for speed rather than brute mass. That is a completely different animal from what we'd been imagining for decades. Here's a fact that surprises most people. Megalodon and the great white are not close relatives. They are distant cousins who happen to be large sharks at different points in history. The position of the Otodus lineage within lamniforms remains unclear. Using the great white to reconstruct Megalodon is a bit like figuring out what a gorilla looks like by scaling up a human. Related? Sure. Accurate? Not really. So how big was it? According to a major 2024 reconstruction published in Paleontologia Electronica by an international team of 26 experts, the species likely reached at least 50 feet, with some estimates pushing to 80 feet in the largest individuals. A 30-foot range of uncertainty for a single animal, because all we have are teeth. Research suggests a 16-metre Megalodon had a head approximately 4.65 metres long, a dorsal fin 1.62 metres tall, and a tail nearly 4 metres high. That dorsal fin alone would have been visible from a beach, and the bite? Estimated at 10.8 to 18.2 metric tons, potentially 10 times stronger than a great white's, the most powerful bite of all time. Fossil evidence suggests Megalodon hunted large whales by biting off their tails and flippers first. It didn't just bite whales, it disabled them, surgically, systematically. That's not a predator, that's a weapon with fins. Now let's bust some myths. The internet has been lying to you. Myth 1. Megalodon is probably still alive in the deep ocean. This one will not die, so let's kill it properly. Megalodon shed tens of thousands of teeth over its lifetime. Those teeth fossilize extraordinarily well, found on every continent in shallow water sediments worldwide. If Megalodon were alive today, we would be finding fresh, unfossilized teeth constantly. We find zero. The fossil record stops cleanly around 3.5 million years ago. No credible evidence supports survival in modern oceans, and the deep ocean argument collapses under basic biology. Megalodon was a warm water coastal predator that hunted large marine mammals in relatively shallow seas. The deep ocean is cold, dark, and devoid of the massive prey it needed. A 60-foot predator with enormous metabolic demands does not quietly retreat to the Hadal zone and go undetected for 3.5 million years. That's not how biology works. That's a really good scary story. Myth 2. Megalodon was basically a great white, just bigger. Previous reconstructions gave them the same body shape. The newer research argues this comparison is at odds with the available evidence. Megalodon was relatively longer and more slender. Different family, different body plan, different animal. Myth 3. The biggest teeth tell us exactly how big the shark was. Tooth size scales with body size, but the relationship isn't perfectly linear, and teeth from different jaw positions are different sizes. Comparing them as if they're equivalent would be like measuring someone's height by their pinky finger. You'd get a number, it wouldn't necessarily be right. Now for the counterintuitive revelations, the facts that genuinely stunned researchers and should stun you too. Revelation 1. Megalodon was warm-blooded. Most sharks are cold-blooded, but a study published in the Proceedings of the National Academy of Sciences provides the first empirical evidence of warm-bloodedness in Megalodon. Using clumped isotope thermometry, reading chemical signatures locked inside fossil teeth, researchers found Megalodon could raise its body temperature around 7 degrees Celsius above surrounding water. It was endothermic. This kept its muscles and brain warm, improved metabolism, and let it swim faster, endure colder environments, and hunt more efficiently. That metabolic fire is part of why Megalodon could grow so enormous. But here's the twist. That same warm-bloodedness may have been what killed it. High metabolic costs associated with endothermy may have contributed to its vulnerability to extinction compared to other shark species that persist today. Its greatest strength became its fatal flaw. As oceans cooled and prey shifted, Megalodon's enormous energy demands couldn't be met. A cold-blooded shark can slow down, conserve energy, survive on less. Megalodon couldn't afford to. It needed to eat, constantly, massively, or it died. Revelation 2. Megalodon was a devoted parent. Fossil evidence from sites like the Gatun Formation in Panama tells a different story than the solitary killing machine we imagine. Researchers analysed over 400 fossil Megalodon teeth from that site, all surprisingly small, representing very young juveniles. Concentrations of juvenile teeth suggest Megalodon used nursery grounds in shallow coastal waters, much like modern sharks. Megalodon pups were already approximately 4 to 5 meters at birth. already the size of a large adult great white, and still considered vulnerable enough to need protected nurseries. The monster had babies, the monster had nurseries. That reframes the whole animal, not a mindless killing machine, but a complex apex predator with life history behaviours we're only beginning to understand. And it's part of why extinction was so final. Around 3 million years ago, sea level oscillations disrupted the coastal habitats where pups were living. Take away the nurseries, and you don't just hurt the adults, you collapse the next generation before it gets started. Revelation 3. The great white shark may have helped finish Megalodon off. At the same time, the great white was starting to evolve and may have potentially been outcompeting the smaller Megalodons. So, we think it was probably down to a combination of less prey availability, more competition, and less habitat, which ultimately led to Megalodon's extinction, researcher Jack Cooper explained. The great white didn't outmuscle a 60-foot apex predator. It outadapted one. Smaller, more flexible, less metabolically demanding, capable of eating a wider variety of prey across a wider temperature range. When the ocean changed, the great white changed with it. Megalodon, locked into its massive body and enormous energy requirements, could not. The formation of the Isthmus of Panama altered ocean currents. Global cooling shrank warm water habitats. Prey evolved to be faster and dive deeper. Megalodon's extinction around 3.5 to 2.5 million years ago was a multi-front collapse. Not one catastrophe, but a slow, grinding failure of everything that had made it king for 20 million years. And here is the most counterintuitive revelation of all. Megalodon's size was both its superpower and its death sentence. The warm blood, the massive bite, the global range, the nursery strategy, the 20 million year dominance, all downstream of one characteristic. It was enormous. And being enormous is only viable when the ocean cooperates. When food is abundant, waters are warm, prey is large and plentiful. Megalodon was the ultimate expression of optimal conditions, so perfectly tuned to a specific version of the world that when the world changed, it had nowhere to go. Too big to adapt fast enough, too hungry to survive on less, too warm to tolerate cold, too specialised to pivot. The ocean didn't lose Megalodon because something beat it. The ocean lost Megalodon because the ocean changed, and Megalodon was too perfectly itself to change with it. And its absence reshaped everything. Some researchers believe the modern ocean, the distribution of whale species, the structure of food chains, was shaped in part by Megalodon's disappearance. The modern composition of gigantic filter-feeding whales was established after Megalodon's extinction. The blue whale, the humpback, the fin whale, the gentle giants of the modern ocean may only exist as they do because Megalodon is gone. Its absence shaped the world as much as its presence did. That is the Megalodon paradox. The most dominant predator in ocean history left behind nothing but teeth, and yet its shadow falls over every ocean on Earth today. Megalodon may have lived up to 88 to 100 years. An individual may have spent a full human lifetime patrolling warm ancient seas, hunting whales, watching the ocean slowly, imperceptibly cool around it. And then one day, not dramatically, not with a bang, the last one died. No witness, no record, just a tooth, drifting to the seafloor. That tooth is still out there. Probably several, washed up on beaches around the world, found by a kid digging in the sand who has no idea what they're holding. A piece of the most extraordinary predator that ever lived, sitting in a shoebox on a shelf somewhere, waiting to be understood. We may never know everything about Megalodon. The mystery is part of what makes it magnificent. The teeth are enough to tell us it was real, enormous, warm-blooded, a devoted parent, dominant for 20 million years, and destroyed by being too perfectly itself. That story, the real story, is more compelling than any movie. So the next time someone tells you Megalodon is probably still out there, smile, nod, and explain why the fossil record, the biology and the ecology all say otherwise. Then watch their face when you tell them it was warm-blooded, that it had nurseries, that the great white may have helped push it to extinction, that its disappearance is part of why blue whales exist. That's the Megalodon that deserves to live on, not in bad CGI, but in the staggering, humbling, endlessly surprising truth of what science has uncovered from nothing but a handful of 7-inch teeth. If this video gave you something to think about, drop a comment below with the fact that surprised you most. Was it the warm-bloodedness, the nursery grounds, the great white connection? I genuinely want to know, And if you want more deep dives into the world's most extraordinary animals, subscribe because we are just getting started, and the next one is going to hit just as hard.